minjani. So lano haina topic yintshwa ya maths la nga ta va ketelana the cubic polynomials or third degree polynomials. Ta va ke factorizer. So leyiwani the remainder theorem. Leyi f of x is equals to the divisor times the quotient plus the remainder. So the remainder theorem can be used to calculate the remainder when a polynomial f of x is divided by ax plus b. Then f of x is equals to minus b over a is equals to r of x. So la, we just substitute factor la, we substitute f of x, then we get the remainder, which makes sense. Kambe the theorem lenje letwana tavan kan ni balabla itona lo untan kan that examples kota ku sitizisa kahle. So yin'wana theorem ya nkoka leyi nga kona hilewa the factor theorem. La ngo if f of x is equals to minus b over a is equals to 0, then a of x plus b is a factor of f of x, and f of x is divisible by a times x plus b. So when trying out x values that gives 0, try them in the following order. So logo faka 1, then logo endly faka minus 1. If no endly faka 2. If 2 endly faka minus 2. If minus 2 endly, continue until you come those the right factors. So lano haita va ki focus ka ti methods leti nga kona leti munhu anga ti tirhisaku ku factorize the cubic polynomials or third degree polynomials. So lano hina factorization by grouping, hina factorization by inspection, then it's like factorization by using the synthetic or long division method. So it method tinaro hinkwato loko u ti tirhisa, not hinkwato kambe leya factorization by grouping only works in certain questions, but leya factorization by inspection na synthetic division yi tirhaka ti examples to tala. So it has sungula factorization by grouping. For factorization by grouping, group terms in two pairs. Then you go take out the common factor from each pair. You go two sets of brackets become common factor or become common factor. Then we'll go factorize bracket further if possible. There's the steps here. So then once I'm going to see some that's one the questions at all at the end. And remember, factorization by grouping does not work for like all the cases to factorize the cubic polynomials. So it's only in special cases where this kind of method is valid. So first step, Sherry, group terms in two pairs. So we'll group this term and that term, and then this term and that term. Right? So then we'll take out common factor from each pair. So then we common factor in x squared. So x squared is 1 x to the power 3 right? As x to the power 1 times x to the power 2 plus 3 by 1 common factor now then equal minus. As we take la common factor imani i4 equal 4 ingena kanaro so it's actually minus 4 instead of 4 common factor so it's minus 4. Then like x, since minus 4 times x then it minus 4x, then you plus 3 minus 4 times 3 money minus 12. then what tantani tabanalis. So lano wana swana kurina common factor legunga x plus 3. We can factor it out. Inga about the bracket. Then lano with the salana money for the bracket. Salana x. Lano with the salana money minus 4. Then waku anlatan whatever wooden stabilization or read two sets of brackets now become common factor. Two sets of brackets now become the common factor, which is this. Then waku factorize bracket further if possible. These ones. You can factorize this even further. So we can do that. Keep doing this. This is the difference of two squares. That's in Latin one example. We think at result method and I'm just one this method does not work. But in this case, it works because we could group these two terms and then group the other ones, then it more common factor. So method law and the factorize by inspection. So we find one linear factor using the factor theorem. Then we'll go find other factor quadratic expression by inspection. As well. So lano alishangana nkoka we have to find a factor. Kumbe kuma value ya x leyi loko hi substitute la ka this equation f of x yi nyiketa a y value ya leyi nga 0. Then that's when we can conclude that x value is a factor of this. Then that factor he multiply by this quadratic expression with the three unknown coefficients a, b, and c. Then we just want to go the coefficients that comes up in as we slope. So the factor theorem here, if minus b of a is equals to 0, then therefore a times x plus b is a factor. So then the same thing. Kukuma the factors. Then we choose the values of x. It's assume plus or minus 1. Then if he inga pasi that plus or minus 2. Then if inga pasi plus or minus 3. Then it continue in the so I assume x is equals to 1. X is equals to 1. We substitute the line in the money. Kita negata this one. The answer alkono kunga minus 12. This is not equals to 0. Therefore, x minus 1 is not the factor. You will know it. We substitute negative 1. That's 3, sorry. Then the no dog answer e. The no dog answer e minus 6. Still na I ring on 0. So it attack x equals to 2. So we substitute in. Then it will answer e, that's 4. Lewa itawa 4, 8. Line at a sorry, this is 3 to the power 3. Laptawa 8, laptawa 8. Like kumokori in 20 minus 20, 0. Which means x minus 2. Because this x is equals to 2, we just have to equate that to 0. So x minus 2 is a factor of f of x. So in Asungu, so now we turn this expression. This is our factor, and then we multiply this factor by the quadratic expression. We've got an unknown coefficient there, or three unknown coefficients, A, B, and C. So I think again with this expression, yiringana na yini, the expression ya inalewa, ya x to the power 3 plus 3. So itagu lisinga laka left hand side, which is this part in y. We'll multiply this thing out. Then it have x times a to the power x to our a to the power a times x to the power 3. Then x times bx, bx squared. Then x times c, cx. Then minus 2 times a times x to the power 2. Itagu minus tabaki continue until minus bx. Minus 2c. Then it has to group the terms lanua tabaki in so liwa ina x to the power 2 na x to the power 2. So we can factor out the x to the power 2. We factor out x to the power 2 the sala b la sala minus 2a. Lanua has one common factor x. So we can factor that common factor. Then the salana c ngaliwa lanua ya salana minus 2b. Lanua the salana 2c. So in order for in order for the left hand side, we got this expression. We have to equate the coefficients. So as one of the coefficient there, x to the power 3 and a1. So in this case, it will go x squared is equals to, then it divided both sides by x to the power 3. Then it will go a is equals to 1. It does the same thing now. It will go 3x to the power 2 should be equal to x squared. La kumagwini, he divided both sides x, takumaku, na b, la a equal 1. Then he saw 2 alaga right hand side, takumaku, b in money, it's 5. A because c, we can either use this expression or that expression, talking about the same answer. Kambeku lewa hiyo the constant term aina x na lewa it's a constant term aina x ita equate at all. Like mago c for sikis. Oh, so ita weka x original f of x lying on x minus 2. The substitute coefficients die in as usual. That fakadala. So in x squared, b in 5, so this is 5 x. C in money 6. And then as we can factorize this expression, this quadratic expression even further. Then it will come in x plus 3, then x plus 2. Then you factorizing this cubic polynomial by using the inspection method. So yeah, and as one of this expression, if I'm not laying logo factorizer by grouping.